substances. Then we had done what are mixture. In the colloids. So the last we were doing here, the Tyndall effect. What is Tyndall effect?
Sir, the scattering of light when passed through any solution or object where the light will be scattered due to the particles
Hello,
present.
sir.
Yes.
Sir, when will you be giving us the marks for the test for Sunday?
Yeah, your test marks will be given today only. Actually, I would have provided it today by 10 p.m., but my laptop went some problems.
Yes,
Okay.
sir.
So that's why I was not able to provide it. It got repaired just now, and I'm able to take your class. Otherwise, even the class would have cancelled today. Okay. So just it will be checked up today and will be
Okay,
submitted.
sir.
Will be given to you. Okay.
Yes, sir.
Okay. A few of them I have checked, and also to an idea, since all of you, when you are scanning your answer sheets, name it with your name. Okay. Save it with your name. We have difficulty in finding out the whose answer sheet is which one. Okay, so let's see the properties of solution. And concentration of the solution. Had we done about the concentration of solution also? See, a solution, it is a homogeneous mixture. The particles of a solution are smaller than 1 nanometer. 1 nanometer means 10 to the power minus 9 meters. So the particles of solution, they are smaller than 1 nanometer in diameter. So they cannot be seen by naked eye. Also, they do not perform scattering of light. And the solute particles, they cannot be separated by the physical methods of filtration. You cannot separate them since the particles themselves, they are very small. Whereas the size of the holes in a filter paper, they are about a micrometer. Okay. So a micrometer or a millimeter, maybe 10 to the power minus 4 or minus 5, that is the size of the pores in the filter paper. So a filter paper cannot be used to separate the contents of a solution. Then we had seen what are suspensions. See, suspension is a heterogeneous mixture. A heterogeneous mixture. What are heterogeneous mixtures?
Sir, where the particles form a separate layer.
Yeah, when the particles can be seen separately. When the particles can be seen separately, we call them as we call those substances to be heterogeneous. So they are not uniformly mixed. When the particles are not uniform, then we call them to be the heterogeneous mixtures. So suspensions, they are heterogeneous mixtures, and particles of suspension can be seen with the naked eye. The particles of suspension are of the size of a few millimeters. So these particles, they can easily be seen by your naked eye. What about their filtration? Can the particles of suspension be filtered through a filter paper?
Sir, some of
Yes, sir.
the mixtures can be and some cannot be.
No. Particles of a suspension, they can be separated by a filter paper. If it is a suspension, so it can be filtered out. Since the size of the particles is greater than the size of the pores. Hmm?
Okay, sir.
So the solute particles either settle down when the suspension is left undisturbed, that is, a suspension is unstable. So if you keep a suspension, like if you keep a mixture of chalk powder and water, so chalk powder will settle down at the bottom. Or if you keep a mixture of soil and water or sand and water, so your sand will settle down at the bottom. Now, when the particles settle down, the suspension breaks and it does not scatter light anymore. So about the scattering of the light, when you will when the particles in the suspension, when the solute particles, they are distributed, when they are distributed, so they will perform scattering of light. Okay, so they will perform scattering of light, but when they settle down at the bottom, then they will not perform scattering of light. So see, first here this point says the particles of suspension, they scatter a beam of light passing through it, and it makes its path visible. So if you have a suspension of a chalk powder, so over there you will find the different contents, they are visible, and if you pass a light beam through it, it will scatter the beam of light.
Sir, that means all the heterogeneous mixtures show the Tyndall effect.
Pardon?
Sir, all the heterogeneous mixtures will show the Tyndall effect or only suspensions?
All the heterogeneous mixtures show Tyndall effect. Okay. The Tyndall effect, it depends on the size of the particles. If the size of the particles is very small, so you will not observe any Tyndall effect.
Okay, sir.
Okay, so that is only with the true solutions or solutions that you have the particles are very small, and over there we do not find any Tyndall effect. There is no scattering of the light. Okay. Now the colloidal solution. See, these two solutions and suspensions, most of the students, they understand it very well, but the problem lies with the colloidal solution. Okay. Generally, the students, they are not able to find out that which solution will be a colloidal solution. So for the colloidal solution, size of the particles, these colloidal solutions, they appear to be homogeneous. They look to be homogeneous. Like, you cannot see the particles. The particles are invisible. Since the particles are small, so they are not observable with the naked eye. You cannot observe them with the naked eye, but they are dissolved in such a way that it appears to be a homogeneous solution. But they are not homogeneous solutions. They are not true solutions. They are colloids. Here, the size of the particles is greater than those of the true solution and smaller than those of suspensions. For example,
Sir, I have a doubt.
yeah,
Sir, in colloidal solution, then the particles are completely not uniformly distributed, sir.
yeah. There are some of the colloidal solutions. There are some colloidal solutions which are unstable. Okay. There are certain colloidal solutions which are unstable. There are certain colloidal solutions which are stable. Okay. So the stability of the colloidal solution, it determines whether it is if uh, if it is almost you can say uh, if it is a lot of heterogeneous. Okay. So then the colloidal solutions, they turn out to be unstable to a very high extent. When you form the colloidal solution, it gets so the colloidal solutions which are formed, they will be just distributed. If they are not stable, they will break down.
Yes, sir.
Okay. So I will tell you the ideas. Generally, for the colloidal solution, you have to observe the size of molecules. Here, the size of molecules is large. We are not going to about the particles. We are dealing with the molecules. So the molecules are larger. Solute molecules, they are bigger in size. Molecules of the solute, they are bigger in size. Generally, they are polymers. For example, in case of milk, we observe that milk contains proteins and milk contains fats.
Right.
Okay, so milk contains proteins and fats. Both of them, both proteins and fats, they are large molecules. They are big molecules. The proteins, they are long polymers. Fats are also big molecules. So you have a number of large molecules. They are uniformly distributed in milk. Okay. Now, if I talk about the stability of milk, okay, milk is a colloidal solution with size of particles between those of suspensions and true solutions. Here, the size of the particles or the particles themselves, they are not visible. Okay, but the particle size is so big that it cannot be. The particle size is so small that it cannot be separated with the help of the filter paper, and it is so big that it doesn't form a uniform true solution, right? So it will break up as you if you put milk for some time. Okay, if you put milk for some time, if you do not put it in a refrigerator, just put it outside for some time. So we observe that the colloidal solution milk, it breaks up. Okay, which we also call as the curdling of the milk. Curdling of the milk occurs. Got it? So during the curdling of the milk, it shows that milk contains the different particles, proteins, fats, and there are different other particles. Okay, so because of the presence of these big molecules, we call milk to be a colloidal solution. Okay, so the size of the particles is that big that it can perform the scattering of light. The scattering of light or Tyndall effect can be observed through the colloidal solutions. Okay, here you can see a torch is lighted through two solutions. You have a true solution and a colloidal solution. So when the light passes through the true solution, we do not observe the path of light. The path of light is not visible through the true solution. Okay, and the path of light is visible when it passes through the colloidal solution. See, when it passes through the colloidal solution, here we can see actually the path of light. We can see the light traveling through the solution. So you can observe this through milk. You can observe this through a soap solution or a detergent solution. You can observe it through a starch solution. So different examples of colloidal solutions. You can consider soap solution, detergent solution, milk, soap and detergent solutions. We have milk, which is a colloid. Then we have starch solution. So the particles or the molecules of starch, the molecules of soap, the molecules of detergent, they are too big. Okay, they are polymers, they are too big, and hence they can perform the scattering of light. But they are not that big that it can be seen from the seen with the naked eyes. Here, in the case of suspensions, it's not single molecule. Each molecule is not split, but you have small particles which are made up of the molecules. There are a number of molecules which are there, but in the case of colloidal solutions, each molecule has split up. We have individual molecule forming the solution. Understood about the colloidal solutions?
Yes, sir.
Okay. If you observe, see, what actually I want, see, this understanding of this is quite easy. If you have sodium chloride, so a molecule of sodium chloride, it consists just of two atoms. Okay, so sodium chloride molecule, it consists of two atoms, and if you form its solution, it forms Na plus ion and Cl minus ion. So the particles become very small. Okay, so Na plus and Cl minus. So as we know that size of Na plus and Cl minus, this is of the size of approximately each atom, and atoms are very small. The size of atom is very small. So therefore NaCl molecule is a very small, and if we dissolve NaCl in water, so the solute particles, they are very small and they will not be visible. Also, they cannot be filtered out through the filter system. But if I am taking chalk powder, okay, so the particles of chalk powder, see, the particles of chalk powder, they do not break into individual molecules. Okay. They do not break into individual molecules. You do not have individual molecules here. Okay, so it is a cluster of molecules. If I say a chalk powder particle, so a particle of chalk powder is a cluster of molecules. It is a cluster of molecules. Okay, so definitely the size of the chalk powder will be bigger in size. If we have a cluster of molecules, a group of molecules are there for the chalk powder, so they will be bigger in size. The size will be bigger. It will be approximately of the size of few millimeters. So they can be easily observed with the naked eyes. Even if you make a solution of sand, a sand solution. So in the sand solution, the particles of sand, again, they are cluster of molecules. Sand particle is a cluster of molecules.
Sir, but sir, so these two solutions will not be stable for much time, no, sir?
Yeah, so they will not be stable for much time. It is again cluster of molecules. So it will not be stable for much time. Now, if I observe the colloidal solution, so in the colloidal solution, you have individual molecules being dissolved in it. So in the colloidal solution, you have big molecules, but the molecules are single. Okay, so it's not a cluster of molecules. Remember, in the colloidal solution, we do not have cluster of molecules, but there are molecules, themselves they are big. Okay. No cluster. So it's not a cluster, not a group of molecules, but the molecules themselves, they are bigger. So the particles, they are bigger in size. For example, a long chain of carbon, which will be a long chain of amino acids together form proteins. Long chain of amino acids, they form proteins. Similarly, fats are also long chains. So these particles, they are bigger in size than those of the true solutions, and hence they can scatter the beam of light. Here we will observe Tyndall effect. Size of the particles is big. Okay, and also the size of the particles is not as big as suspensions, since these are single molecules. Okay, so starch is also polymer. So if you find out solution of starch, if you find out a solution of detergents, just one. So see, you have. So understood about the colloidal solution? Anyone having any doubt from these three types of solutions? No.
Right.
So properties of the colloid. Now see, here we have some questions. Question, first one, you have to differentiate between homogeneous and heterogeneous mixtures with examples. So Rohit, can you give me some points for the difference between the homogeneous and heterogeneous solutions?
Sir,
Yes.
yes, sir.
Yeah, Pranav, I think I was explaining the colloidal solution only from such a long time. Did you join late? Huh?
Sir, uniform, homogeneous mixture have a uniform composition, whereas heterogeneous mixtures do not have a uniform, have a non-uniform composition.
Okay. Okay. So homogeneous mixtures, they have uniform composition, and heterogeneous mixtures, they have non-uniform composition. And can you give examples?
Sir, sir, water and oil.
Water and oil. Okay. It is a heterogeneous or homogeneous?
Sir, homogeneous is water, heterogeneous is oil.
No. So what are the solute and solvents? Mixture means there have to be two substances in it.
Yes, sir.
So can you give me examples? Yeah, Sampath, can you give the examples of homogeneous and heterogeneous mixtures?
Yes, sir. For homogeneous mixture, we can have a copper sulfate solution, salt solution, sugar solution. For heterogeneous mixtures, we can have chalk powder and water, and also the small stones and water, and
Okay.
also oil and water.
Okay, very good. So for question number 2, how are Sol solution and suspension different from each other? How are Sol solution and suspension different from each other?
Sir, what is salt solution, sir? Sir,
I will tell. I will tell. Just anyone can answer. How are Sol solution and suspension different from each other? Anyone can think of what are Sol?
sir, soluble solutions.
No, sols are colloids where solid particles are dispersed in liquid. So sols generally refer to the colloids. Okay. Okay, so now so basically in question number 2, you have to differentiate between solutions, suspension, and colloids. You have to. So I think you can do that. This is your homework. As your homework, you will be completing the difference between solution and colloids.
Okay, sir.
Okay. Okay. Now at question number 3, to make a saturated solution, 36 gram of sodium chloride is dissolved in 100 gram of water at 293 Kelvin. Find the concentration of this solution. So can you find the concentration of the solution? Yes, can you find the concentration of solution? The concentration of solution. Yes, can anyone give the concentration of solution?
So first you have to find the solution, right? Mass of solution.
The formula for the concentration of solution is given as
It's mass of solid by mass of solution
mass of
into
solute
100.
over mass of solution into 100.
So but first you have to find a saturated solution, right?
Yeah, so you have to make a saturated solution. You are given 36 gram of sodium chloride is dissolved in 100 gram of water at 293 Kelvin. So everything is given. Mass of solute is given. Mass of solvent is given.
So 36 gram by 100 into. So first I think we have to add 100 plus 36.
Okay. So see, to find out the concentration of solution,
Sir, is my answer correct? I sent you in the chat.
yeah, just I'm checking it. So Sampath, you have sent two answers. There should be just one answer.
Sir, no, sir. The first one what I said was it is recurring, and then I rounded off it.
Okay.
Sir, I round it off and also
So
send
here
it.
this question. You have to make a saturated solution with 36 gram of sodium chloride. So use the formula of concentration being given as mass of solute. It has to be mass of solute divided by mass of solution over 100. Multiply 100. Okay. So mass of solute is 36 divided by mass of solution, which is 293, and multiply it by 100. So you get it. Okay. So it would be 3600 divided by 2. Oh, sorry. Mass of solution is 136. It's 136. Yeah. 100 gram is water and 36 gram is the sodium chloride. So you have this whole thing divided by 136.
Yes, sir. Sir, we will get 26.4705 and go on.
So we'll get here 3600 divided by 136. Yeah, 26.47. That's 26.5. So you can round it off. This is 26.47, or you can give 26.5%. And you have found out here this concentration is measured in terms of mass. So we call it as mass by mass. 26.5%, you can call it mass by mass percentage.
Sir,
You have
then
different other, yes?
Sir, then there is no need to substitute anywhere the temperature.
What happened? Just repeat.
Sir, there is no need to substitute the temperature when it's given.
No, no need to put the temperature. Okay. The temperature, see why the temperature is given. It's given as the solubility. The solubility of a substance in water or in a substance is a function of temperature also. If you increase the temperature, so the solubility increases. Okay.
Okay, sir.
So that is just as a fact, it has been given that it is making at 293 Kelvin. Now see, our next part is separation of the substances. These things we have already discussed. Physical and chemical changes. Let's now come to the physical and chemical changes, and then we will come to elements, compounds, mixed elements and compounds also. So what are physical changes and what are chemical changes? Physical changes are the changes where we do not bring about a change in the constitution of the particles. Okay, where we do not bring about any change in the properties of the particles. The change in the properties are not protocols. The chemical properties of the substances, they remain intact. So if you are not altering its properties, then it is a physical change. If you are altering the properties, then it is a chemical change. So physical changes are the changes where there are, see, the properties that can be observed and specified, like color, hardness, rigidity, fluidity, density, melting point,
Sir,
boiling
what is
point, etc. Yes,
rigidity?
rigidity means hardness of the substance. For example, how rigid
So is
rigid,
rigidity and hardness same, or are they different?
yeah, they are different. A little bit they are different. Rigid means if you apply a deforming force on the substance, it gets deformed. If it gets deformed, then it's not rigid.
Okay.
Okay, if I am applying a deforming force, it gets deformed, then it is not rigid. If it doesn't get deformed, then it is rigid. For example, if you take the example of iron and coal, okay, so if you apply hammer on iron, so what do you expect will happen? Will iron change its shape or not?
It will.
Yeah, it will change its shape. So can I say that iron is rigid?
No.
No, iron can be deformed. So iron is not rigid. What about coal?
Coal is rigid.
Yeah, coal is rigid. If you hammer the coal, so it will shatter into pieces. But if you think of the hardness, so both iron and coal, both of them are hard.
Yes.
Okay. So now you have understood the difference between hardness and rigidity also. So these properties like color, hardness, rigidity, fluidity. Fluidity means the property to flow. Fluidity, density of the substance. So the density of the substance changes. Density means mass per unit volume. So density of the substance, melting point, boiling point, etc. They are all physical properties. So when we think of the physical properties, we'll be thinking of these properties only, like color, hardness, rigidity, fluidity, density, melting point, boiling point. So these are physically observable. Those physically observable quantities, they are called as physical properties. So if you bring about any change in the physical properties, so such changes are called as physical changes. For example, if you bring about a change in its hardness, if you bring about a change in its shape, change in its size, so they are the physical properties. The interconversion of states is a physical change because these changes occur without a change in composition. So you do not bring about any change in the composition. That is a physical change. Okay. So what about cutting a wood into pieces? Is it a physical change or a chemical change?
Physical change, sir.
Okay. Cutting of wood into pieces is a physical change. What about tearing of paper?
Sir, physical change only, sir.
Physical change. Tearing of paper is a physical change.
Yes, sir.
Okay. And what about burning of coal?
Sir, it's a chemical change.
It's a chemical change. Cooking of food?
Sir, a physical change.
No. Cooking of food is a chemical change.
Sir, why is it a chemical change? What is the reason?
We are changing the constitution. We are changing the properties of properties of them. Constituting particles. We are changing the properties of the constituting particles.
Yes, sir.
So that is cooking is a chemical change. What about curdling of milk?
Sir, chemical change.
Yeah, curding of milk is a chemical change. We have a change in the property of milk. The taste and the taste changes, flavor changes, and we have the change in chemical property that it becomes acid. So curdling of milk is a chemical change. See here, some changes are given. Classify the following as chemical or physical changes. So cutting of trees.
Sir, physical
Yes, I
change.
didn't. Physical change. Melting of butter in a pan.
Sir, chemical change.
Sir, is it a physical change?
Yeah, it is a physical change. When you are bringing about a change of state. Okay. Bring about a change of state only.
Yes,
That
sir.
is a physical change. Rusting of almirah.
Sir, chemical change.
Chemical change. Okay. Boiling of water to form steam.
Sir, chemical.
Chemical. Okay.
Sir,
Boiling of
the
water to form steam. Is it a chemical change?
No, sir, it's physical, sorry.
Yeah, it is a
Physical.
physical change. Okay. What about other people? I don't observe Jitendra, Yukta, Mohammad Rayan. These people, they are not
Yes, sir.
responding. I already informed you, if you keep your cameras on, then you will be the first one to be called off. Okay. Is that the reason why you keep your cameras off? See, become an active participant of the class. If you are just becoming a passive participant, so it will be just like that you are observing a video, okay, and not you are not participating. So become an active participant, right? Maybe you are having some doubt, maybe you are not having any doubt, but speak up whatever answers you know. If you do not know the
Okay.
answers, so then ask, I do not know, inform. Okay. So, Sharwan, what about the rusting of almirah?
So it's a chemical change.
It is a chemical change. So, what chemical composition is being changed during
So
the
what?
rusting of almirah? During the rusting of almirah, what is the how the chemical change is brought about?
I don't know.
See, during the rusting of almirah, the iron oxidizes with oxygen, or iron reacts with oxygen to form iron oxide. So it is a chemical change. The composition is changed. Here the composition is changed. Then boiling of water to form steam, it is just a change of state. We are not changing the composition of water. So since composition of water is not changed, so it is a physical change. Passing of electric current through water and the water breaking down into hydrogen and oxygen
Sir, it's a
gases.
chemical change, right?
Yeah, it is a chemical change. Okay, what about when you pass electric current through a bulb? Is it a physical change or a chemical change?
Sir, chemical.
Chemical change.
When you pass electric current through the filament of the bulb and the filament start glowing.
Sir, physical.
Yeah, it is a physical change. Dissolving of common salt in water,
Sir, chemical change.
Sir,
Physical change.
physical change.
it is a physical change. See, we already discussed that dissolution is a physical change. When you dissolve a substance uh, in another substance, so it is a physical change. So dissolving of common, yes,
Sir, but when we dissolve salt in water, won't it form ions?
yeah, it forms ions. But are we changing the composition of water?
Oh, okay, sir.
Okay, we are not changing the composition of water. Water is still water, and hence it is a physical change. Making a fruit salad with raw fruits.
Sir, physical change.
Yeah, it is a physical change.
Yes, sir.
Burning of paper and wood.
Sir, chemical
Sir,
change.
physical change.
Okay. Now the next things. What are the types of pure substances? So now
Sir,
we
elements
had.
and compounds, right?
Okay. So first of all, what are pure substances? I think we had discussed what are pure substances. So
Yes,
can
sir.
anyone remind me what are pure substances?
Sir, I can.
Sir, a pure substance is a single kind of substance which cannot be separated into other constituents.
Yeah. Pure, pure substances are the substances which are made up of similar type of particles. If all the particles, they are similar to each other in all respects, in respect of their masses, in respect of their composition, in respect of their uh, other properties. So if all the properties are similar, then we call them to be pure substances.
Yes, sir.
For example, if you have sugar, so if I have crystals of sugar, so can I call it to be a pure substance or impure substance? Sherman, what will I call? If I have crystals of sugar, that means if I'm having 1 kilogram of sugar, so what should it be? Pure or impure?
Pure.
Yeah, it is pure. However, sugar itself, it constitutes of the formula of sugar is C12H22O11. See, sugar itself, if you identify sugar, so sugar is chemically C12H22O11, right? So this is the formula of sugar. That means sugar itself consists of 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen. But still, a sugar molecule is pure. Why? Because all the sugar molecules, they are similar to each other. Okay. So if all the particles, they are similar to each other, they are exactly same to each other, we call them to be pure substances. Now here we have two types of pure substances. We have seen the types of impure substances. Okay. Yukta, what are the types of impure substances? Yukta? Yukta, if you are there and you can, if you are hearing, so can you respond even through the chat section? Yeah, Yukta, are you there? Okay, just hold on for 1 minute. Okay. Okay, Sampath, yeah, Sampath,
Sir, homogeneous and heterogeneous.
homogeneous and heterogeneous. Okay, so what are homogeneous and heterogeneous?
Sir, they are the types of mixtures.
Okay, they are the types of mixtures. Very good. So for the types of mixtures, or if you look at the types of impure substances, we have classified them as homogeneous and heterogeneous. And then further, they have been classified into true solutions, suspensions, and colloids. Okay. Now the pure substances, if you think what are the different types of pure substances, so pure substances can be classified under two categories. Pure substances, they can be either elements or they can be compounds. Elements or compounds. Okay. So elements are the one which constitute of only single type of the particles. They are the purest form of matter and they constitute, or I can say that they are made up of single type of particles. Made up of single type of particles. So they are the elements. They are the purest one. Then they are similar in all respect. The elements of an atom, they are similar in all respect. For example, if you find out the atoms of carbon, so atoms of carbon will be similar to each other. Now compounds, they are made by combining the elements in fixed ratio. So they are always formed by combining elements in a fixed ratio by mass. So here elements are combined in a fixed ratio by mass and they are chemically bonded to each other. They change the properties of the element. So they change the properties of the combining element. For example, the example of compounds are carbon dioxide, H2O, CH4, all of these, sugar, glucose, C6H12O6, which is glucose, salt, NaCl, acid, HCl. So all of them, they are compounds. Okay. So compounds can also be pure. If you have all the molecules of HCl only, if you have all the molecules of carbon dioxide only, if you have all the molecules of water only, okay, so it is a pure substance. But in the similar way, elements, for example, you can have hydrogen, chlorine, oxygen, yeah, argon, all of them, they are elements. So elements can be pure or impure. Okay. So
Sir,
understood what are pure substances and how we can classify the pure substances?
yes, sir. Sir, in compounds, the compounds which are formed from the elements, they won't show the properties of any of the elements.
Yeah, they won't show the properties of the elements. Now they will have their different properties. They are now their properties will have changed and their properties will be defined by the chemical relationship between the combining atoms. How they have been combined. Now their properties will be defined in a different way. For example, we can think of carbon and oxygen. See, carbon is a fuel, it burns out. Oxygen is a supporter of combustion, and both of them, when combined in a fixed ratio, they form carbon dioxide. Now, carbon dioxide is a gas and it has its different properties. It extinguishes fire. Carbon dioxide now is it is not good for inhalation.
Okay, sir.
So the properties of the combining elements are changed. Got it? So you have the pure substances, they are divided under two categories, elements or compounds. Elements are made of single type of particles. Single type of particles means all the atoms they are made up of atoms where each atom what are elements? And here some properties of metals are given. Some physical properties of metals and non-metals they are given. So first we have listed out some properties of metals. So the physical properties of metals, where metals have luster, that means they shine. They have silvery gray or golden yellow color. They conduct heat and electricity. They are ductile. That means you can make wires of them. They are malleable also, and they are sonorous. So that means they make ringing sound when hit. So all these they are the physical properties of the metals. But these elements or these metals, when they combine with other substances, their properties change. All their physical properties change when they combine with other substances. So compounds, we have already discussed that compounds, they are formed by combining of the elements in a fixed ratio. Here a difference is given between mixtures and compound. So in mixtures, the properties of the combining elements is unchanged. The combining elements, they retain their properties when they form a mixture. Whereas when the compounds are formed, the elements, they do not retain their properties. Whereas to form when the mixtures are formed, elements just mix up, either elements or compound, they just mix up and they can be mixed up in any ratio. There is not a fixed ratio that you will always find a mixture in a fixed ratio. But compounds, here the elements react chemically with each other to form the compounds. And a mixture can have a variable composition. That means the composition of mixture can change. It can have different concentrations. Whereas the concentration of the compound remains the same. The composition of each new substance is always fixed. For example, if you are having carbon dioxide, so in carbon dioxide, you will always find one atom of carbon. You will have one atom of carbon and two atoms of oxygen. If you find out the ratio of their masses, so the ratio of their masses will always remain the same. It will be 12:32. So 12:32 simplified, that will be the ratio of carbon and oxygen in carbon dioxide. But for the mixtures, the ratio is not constant, the ratio can change. Okay. So from our in the next class, we will start after this mixtures and compounds. So just go through this mixtures and compound. We will do once more compounds. Compounds we will do once more, and then we'll move ahead. Okay.
sir.
So be ready with your doubts. If you have any doubts, be ready. Okay. Bye all of you. See you again on Saturday.
Bye, sir.
Very good.